Hello everyone, Dr. Matt Ed. Today we'll be talking about steps to read EKG. So 5 things are needed to read an EKG adequately, and that includes rate, rhythm, axis, intervals, and morphology. Within morphology, there are 5 other things as well, and that can be memorized by using the mnemonic QR BEST. So this stands for Q waves. To take a look at any Q waves on the EKG. Look for R wave progression and look for blocks such as right bundle, left bundle, or if there's any AV nodal blocks. Look at enlargements, if there's atrial enlargement or ventricular enlargement or LVH. And finally, ST changes like T wave inversions or ST elevations or ST depressions. These are the EKG features of normal sinus rhythm. The rate is regular at a rate of 60 to 100 beats per minute. QRS complex is preceded by a normal P wave. A normal P wave is defined by P waves upright in leads 1 and 2 and inverted in AVR. The PR interval remains constant throughout the EKG, and QR complexes are less than 100 milliseconds wide unless there is interventricular conduction delay. To figure out the rate, there are 2 methods. First, the large square method. Essentially, you divide 300 by the number of large squares between R to R interval. This is useful for regular rhythms. For example, as shown here, if between 2 R intervals you got 3 large boxes between, 300 divided by 3 gives you 100. But if the rate is irregular, such as patients with AFib, you count the QRS complexes throughout the whole strip, and then you multiply by 6 because each EKG strip is 10 seconds. So 10 times 6 gives you a minute. So like I mentioned before, this is the second method, also known as the R wave method to calculate the rate. Rate equals number of R waves throughout the rhythm strip times 6 because the strip itself is 10 seconds. So 10 times 6 gives you a minute. So again, it's useful for irregular rhythms. After rate, you look at the rhythm, if it's regular versus irregular. So regular will be the intervals are constant, the R to R intervals, whereas irregular, the R to R intervals will not be constant, such as in AFib. So here, for example, these are regular rhythm. All these are pretty much constant. Whereas in AFib, the R to R intervals are not regular, they're irregular. Next, we'll talk about axes. So normal axis from here shows 0 to 90, this side. Left axis deviation is 0 to negative 90 degrees, so left upper. Right axis deviation is 90 to 180 degrees, so left lower. The extreme axis is negative 90 to 180 degrees, and it's left upper. So the main leads you want to look at is, the main leads are lead 1 and lead AVF. If both are positive, then it's normal. If lead 1 is positive and lead AVF is negative, then it's left. If lead 1 is negative and lead AVF is positive, then it's right. And if both are negative, then it's extreme axis. So easy way to remember this is the thumb method. Thumbs up are positive and thumbs down are negative. So we use both hands. Left hand, left thumb represents lead 1, and right hand, right thumb represents lead AVF. So this is left and this is right. The determination of whether these are positive or negative depends on the QRS. If QRS is positive and pointing up, then it's positive. If QRS is pointing down, then that's negative. So if lead 1 and ABRF are positive, then both thumbs are up, so that signals good, and that's normal axis. If left thumb is up and right thumb is down, then that signals the left side takes over, so it's possible left axis deviation. If left thumb is down and right thumb is up, so it swings over to the right side, so that's right axis deviation. And if both thumbs are down, then it's bad, and that's extreme axis. Here are the intervals, and these are the normal intervals for a normal EKG. QRS is 0.08 to 0.12 seconds. QT is 0.36 to 0.44 seconds. And PR intervals is 0.12 to 0.2 seconds. And lastly, remember the mnemonic Q are best for morphology. So you see if there's any Q waves. Look at the R wave progression to see if there's any poor R wave progression. Look at blocks. Check if there's any right bundle, left bundle, or avinodal blocks, or complete heart block. Look at if there's any enlargements of the atrium or the ventricle based on EKG morphologies. And then look at to see if there's any ST changes, such as ST elevations, ST depressions, or T wave inversions. And this is your reference, Life in the Fast Lane. If you thought this video was helpful, please like, subscribe, and watch out for my next video. Thank you for watching.